Okay, Rihanna asked this question. Thanks for asking this question. I appreciate it. Number 6. So you got this rocket. It's 5 kilograms. It's right there. And it's launched directly upward from Earth's surface. So when it starts, it's on the surface of the Earth. The distance between the rocket and the center of the Earth is basically the radius of the Earth. Good enough. And when it's right there, it's being launched, so it has an initial velocity of 10 kilometers per second. So it's moving pretty quick. Now, when it's at this spot right here, it has a certain universal gravitational potential energy and it has a certain kinetic energy. You can figure those out. Then it's launched, okay? At what altitude does it reach? What's the highest point it reaches? Well, that's what we're calling the altitude, right? We want to calculate that. Well, when it reaches its highest point, its speed will be 0. So when it's at this point, you can calculate the kinetic energy of the object, the rocket, and the gravitational potential energy of the object, and that would be universal gravitational potential energy, big G. What's up, big G? All right. So you can use these quantities, EGF, EKF, EGI, EKI. You can use these to find out just how high it gets above the surface of the Earth, the altitude. All right, so that's number 6A, I think you asked for, Rihanna, if I remember correctly. And you also asked for 7. So you got a neutron. So I'm going to represent the neutron with this purple ball. We know the mass of the neutron. It's traveling away from the sun. Here's the mass of the sun. Now, when it's at a point of 1.4 times 10 to the 9 meters away from the sun's center. So look what I've drawn here. Here's the sun. There's the center, and this red line represents radius initial, RI. That distance right there, that's how far it is from the center of the sun. And when it's at that spot right there, it's got a certain speed, VI. I don't like that V, let me fix that. Okay, VI, right there. And we know what that is. So that means when it's here, we know its speed and we know its position from the center of the sun. Therefore, we can calculate its universal gravitational potential energy and its kinetic energy right here. So it's moving away from the sun, and at some point later in time, it gets to this spot right here. And this spot right here is a certain radius, RF, away from the sun. And we know how much that is. RF is 2.8 times 10 to the 9 meters. So when it's that far away from the center of the sun, right, it's a new distance from the center of the sun, what we want to calculate is its speed there. That's what we want to do. And we'll use things like universal gravitational potential energy initial, kinetic energy initial, universal gravitational potential energy final, kinetic energy final. We'll use all these things to calculate it. So that's 7A. B, prove mathematically if the neutron will escape. Well, what does escape actually mean? How do we quantitatively define that an object can escape from the gravitational influence of the sun? You got to find that out because that'll give you an equation to work through. But I think that's enough of a hint. Anyway, thanks for asking the question. I really appreciate it, and we'll see you next time. Bye bye.